Imagine a quiet summer night, deep within the heartland of America, where machines tirelessly scan the cosmos for a whisper from beyond. Then, a single, anomalous burst of data erupted, a chilling scream from the void that lasted precisely 72 seconds and redefined humanity's place in the universe. This is the story of the WOW signal, an enigma born in the cold data streams of a long-vanished observatory, a phantom broadcast from the abyss that continues to haunt astronomy, echoing with the profound and unsettling question, are we truly alone? For nearly 5 decades, this fleeting glimpse of something truly extraordinary has eluded all explanation, leaving behind a legacy of desperate searches, fervent speculation, and a gnawing sense of what might have been. It is a tale not of discovery, but of an almost discovery, a cosmic tease that reminds us just how vast and silent the universe can be, and how terrifyingly close we might have come to hearing a voice from the stars. The year was 1977, a time when humanity's gaze was fixed firmly on the heavens, spurred by a relentless curiosity about our cosmic neighborhood. On a sprawling tract of land in Delaware, Ohio, stood the Big Ear radio telescope, an unassuming titan of steel and mesh that was, at the time, the longest continually operating radio telescope in the world. Its mission, however, was far from ordinary. Big Ear was not merely observing distant galaxies, it was listening. Specifically, it was part of the SETI program, the Search for Extraterrestrial Intelligence, a monumental undertaking predicated on the hope that somewhere, across the unimaginable expanse of interstellar space, another civilization might be broadcasting its existence, a beacon awaiting interception. The method was simple, yet profound. The telescope would scan the skies, collecting radio waves across a specific range of frequencies. These signals would then be fed into a bank of computers, which would tirelessly analyze the data, searching for any pattern, any anomaly, that might suggest an intelligent, non-natural origin. It was a painstaking, often monotonous process, a testament to humanity's enduring patience in the face of cosmic silence. The role of identifying these potential anomalies often fell to a dedicated team of volunteers and astronomers, individuals who committed countless hours to sifting through reams of computer printouts, their eyes scanning for the faintest deviation from the expected noise of the universe. Among these dedicated souls was Dr. Jerry R. Ehman, a quiet, meticulous astronomer working at The Ohio State University's Radio Observatory. Ehman's task on the night of August 15, 1977, was routine: to review the vast torrent of data churned out by Big Ear's computers over the previous days. Each sheet of paper was a grid of numbers and letters, representing the intensity of radio signals detected across different frequencies. Most of it was predictable, a mundane record of cosmic background noise or known celestial phenomena. But then, as his eyes traversed a particular column on one printout, something seized his attention. His gaze locked onto a sequence of characters that defied all expectation, a sudden, explosive surge of power unlike anything seen before. The standard code used by Big Ear's computer represented signal intensity on a scale from 1 to 9, with 1 being barely above noise and 9 being significantly stronger. Anything above 9 was represented by a letter, a 410, B411, and so on. The sequence Ehman saw that night read 6EQUJ5. The 6 was already strong. But then came E, representing an intensity of 14, followed by Q at 26, U at 30, and J at 19, before returning to a 5. This was not merely a strong signal, it was an astronomical roar, peaking at an intensity 30 times greater than the ambient background noise. It was, quite simply, the strongest, most compelling candidate for an extraterrestrial transmission ever detected. Ehman, a man of scientific rigor and reserved demeanor, was utterly stunned. His pen, a tool usually reserved for precise calculations and observational notes, now moved with an uncharacteristic urgency. Circling the anomalous string of characters, he scrawled a single, emphatic word in the margin of the printout, a word that perfectly encapsulated the scientific awe and profound shock of the moment: wow. It was a spontaneous, human exclamation that would forever lend its name to one of the most enduring mysteries in the history of science. What made this signal so uniquely compelling, so different from the countless blips and surges that Big Ear had recorded over the years? The answer lay in its precise characteristics, a constellation of factors that, taken together, painted an almost perfect picture of what an artificial, intelligent transmission might look like. Firstly, its frequency. The wow! Signal registered at 1420.4556 MHz. This specific frequency is profoundly significant in astronomy. It corresponds to the hydrogen line, the precise frequency at which neutral hydrogen atoms naturally resonate and emit radiation. Hydrogen, the most abundant element in the universe, is a universal constant, a fundamental building block. For any intelligent civilization attempting to make contact across vast cosmic distances, the hydrogen line would be the most logical, universally recognizable channel to use, a cosmic greeting card written in the fundamental language of the universe itself. It's like agreeing on a common language before trying to speak. The signal wasn't just near the hydrogen line, it was almost exactly on it. Secondly, its duration was meticulously precise, 72 seconds. This wasn't a random fluctuation. The Big Ear telescope, unlike parabolic dishes that could track a celestial object across the sky, was a fixed-horn reflector. It relied on the Earth's rotation to sweep its narrow beam across strips of the sky. An astronomical source would enter Big Ear's observational window for approximately 72 seconds as the Earth rotated, reaching its peak intensity roughly in the middle of that window, then fading as it moved out of view. The wow! Signal behaved exactly this way, a gradual increase in intensity, a peak, and then a gradual decrease, perfectly matching the expected transit time of a point source across Big Ear's beam. This suggested a distant, stationary source relative to Earth's rotation, not something local and terrestrial. Thirdly, its intensity. As Jerry Ehman had noted, the signal was incredibly strong, peaking at 30 times the background noise. Such power indicated a deliberate, focused broadcast, far beyond the capabilities of natural astronomical phenomena to produce in such a narrow bandwidth. Natural radio sources, like pulsars or quasars, tend to emit across a broad spectrum of frequencies. The wow! Signal was incredibly narrowband, concentrated into a tiny slice of the radio spectrum. This narrowness is a hallmark of artificial transmissions, designed to maximize signal strength and minimize power consumption over vast distances, much like a laser beam compared to a floodlight. Natural sources simply don't produce such tightly focused, powerful bursts at such a precise, significant frequency. Finally, and crucially, the signal appeared in only one of Big Ear's 2 feet horns. The telescope was equipped with 2 receivers, positioned side by side, each scanning a slightly different region of the sky. An intermittent terrestrial interference, like a passing airplane or a car, would likely register on both horns, or at least show some indication of a local source. The wow! Signal, however, was detected by only one horn, then faded, consistent with a cosmic source moving through that horn's specific field of view and then out of range. If it had been local interference, it would likely have been picked up by the other horn 3 minutes later, or it would have shown characteristics inconsistent with a distant astronomical source. It did not. This confluence of precision frequency, exact duration, immense intensity, narrowband nature, and single-horn detection painted a picture that, to Ehman and his colleagues, was almost too perfect. It was everything they had been searching for. It was, by all accounts, exactly what an intelligent extraterrestrial civilization would send. The implication was staggering, intoxicating, and terrifying all at once. For 72 seconds, humanity might have received a deliberate communication from beyond. The initial euphoria within the small, devoted community of SETI researchers at Ohio State was immense, quickly giving way to a frantic urgency. The priority became clear: find it again. If this truly was an intelligent transmission, it might be part of a continuous broadcast, or at least a repeating one. The Big Ear team, along with Ehman himself, immediately began repeated attempts to redetect the signal from the same region of the sky where it had originated, the constellation Sagittarius. They aimed their powerful antennas back towards that precise celestial coordinate, straining to catch even a whisper of its return. Days turned into weeks, then months, then years. Big Ear, and eventually other, more powerful radio telescopes around the world, meticulously scanned the area. They listened with an almost desperate intensity, but the sky remained silent. The 72 seconds of the wow signal became an isolated, singular event, a cosmic phantom that vanished as quickly as it appeared. The silence that followed was not merely the absence of sound, it was a profound, unsettling void, a tangible disappointment that settled over the scientific community. The initial excitement curdled into frustration, then into a deep-seated mystery that has never been resolved. The inability to redetect the signal became its most haunting characteristic. If it was a genuine extraterrestrial beacon, why was it a one-off? Was it a passing message, a burst from a rotating transmitter that only swept past Earth once? Or had the source simply stopped transmitting? The questions piled up, each more tantalizing and unanswerable than the last. The scientific community, though thrilled by the initial prospect, demanded reproducibility, the cornerstone of scientific validation. Without it, the wow signal remained an anomaly, a tantalizing ghost in the machine, unable to transition from intriguing data point to confirmed discovery. Over the decades, as the silence persisted, numerous hypotheses have been put forward to try and explain away the wow signal, to force it into the familiar patterns of known terrestrial or natural phenomena. Each attempt, however, has consistently fallen short of providing a satisfactory, comprehensive explanation that accounts for all of the signal's unique characteristics. The most immediate and common explanation for any strange radio signal is terrestrial interference. Could it have been an Earthbound signal bouncing off space debris, or a secret military satellite, or even a passing aircraft? This was quickly and largely dismissed. The signal's incredibly precise frequency on the hydrogen line, its narrow bandwidth, and the way it tracked across the sky for exactly 72 seconds made it highly improbable for any known terrestrial source. Military transmissions don't typically operate on the hydrogen line, nor do they usually exhibit such perfectly defined transit times consistent with a fixed celestial object. Furthermore, strict protocols were in place at Big Ear to filter out known interference, and none were identified for this event. Another theory, gaining some traction years later, suggested the signal might have originated from a comet. In 2017, amateur astronomer Antonio Paris and his colleague Evans proposed that the wow signal could have been caused by two comets, 266P/Christensen and P/2008 Y2, Gibbs, passing through the Big Ear's field of view at the time. Their argument hinged on the idea that comets, which contain clouds of hydrogen, could emit radio waves at the hydrogen line frequency. While an interesting thought, this hypothesis was quickly and largely debunked by the broader astronomical community. The hydrogen emission from comets is typically spread over a much wider frequency range, not the ultra-narrow bandwidth observed in the wow signal. Furthermore, the intensity of such emission would be far too weak to account for the signal's immense strength. The comets in question were also too far away at the time to produce such a strong signal, and their positions were not precisely aligned with the signal's origin point. This particular theory, though a noteworthy attempt to resolve the mystery, ultimately served to highlight just how difficult it is to find a natural explanation that fits all the facts. It became a brief, flickering hope swiftly extinguished by scientific scrutiny, leaving the original mystery intact. Other suggestions have included everything from undetected meteoroids burning up in the atmosphere, creating temporary plasma trails that could emit radio waves, to a powerful but unknown natural astrophysical event. Yet, none of these theories adequately explain the combination of high intensity, narrow bandwidth, and the exact hydrogen line frequency. The universe, while full of wonders, does not typically create radio bursts that mimic an intelligent, deliberate broadcast so perfectly. This brings us back to the most tantalizing, yet unprovable, hypothesis: the wow signal was indeed a message, a fleeting glimpse of extraterrestrial intelligence. The characteristics that confound natural explanations are precisely those that would be expected from an intentional signal. For many within the SETI community, it remains the strongest candidate for an extraterrestrial transmission. The very qualities that make it an enigma also make it a beacon of hope, a whisper from a distant star. The wow signal isn't just a fascinating historical footnote, it continues to haunt astronomy because it represents a profound psychological and philosophical challenge. Despite lacking scientific proof, thinking about extraterrestrials and extraterrestrial intelligence is part of our psychological reality, deeply embedded in our collective imagination. The wow signal stands as a stark, empirical reminder of this possibility, a ghost in the cosmic machine that refuses to be ignored. Within the scientific community, particularly among those dedicated to SETI, the signal holds a unique and almost revered status. It's like a secret handshake, a shared understanding of a monumental almost. This study enters what could be described as the closed and secluded community of SETI researchers, a cultural milieu where a group of self-identifying people with certain shared beliefs engage in a set of distinctive and mutually understood pursuits. For them, the wow signal isn't just data, it's a foundational myth, a shared experience that validates their tireless efforts and fuels their ongoing search. It's the ghost that walks among them, a constant reminder of how close they once came to altering the course of human history. The enduring legacy of the wow signal lies not in its confirmation, but in its tantalizing uncertainty. It leaves us with a sense of cosmic dread, a profound unease that we might have missed a monumental communication, a lost opportunity slipping through our grasp into the vast, indifferent silence of space. Was it a distress call, a greeting, a broadcast of knowledge, gone forever unheard? The thought creates a chilling vacuum in our understanding. It forces us to confront the terrifying possibility that the universe is not just silent, but that it might have spoken once, and we failed to catch its meaning, or worse, that it will never speak again. Today, Big Ear no longer stands. It was dismantled in 1998, its great structures recycled, its purpose fulfilled, yet its most famous discovery remains stubbornly unresolved. The region of Sagittarius from which the signal originated has been scrutinized countless times by newer, more sensitive instruments, but nothing similar has ever been detected. The coordinates of the wow signal remain etched in astronomical records. A cosmic X marks the spot that yields no treasure. So, the mystery persists, an enduring specter in the annals of science. The 72 seconds of the wow signal are a testament to the persistent human quest for understanding, a stark reminder of the limitations of our instruments, and the vast, unfathomable distances that separate us from potential cosmic neighbors. It is a story of hope, disappointment, and an unyielding question mark hanging over humanity's place in the universe. The wow signal continues to haunt astronomy, not because of what it definitively proved, but because of what it might have been. It serves as a chilling testament to the profound uncertainty that lies at the heart of our cosmic existence. In the vast, silent ocean of space, we may have heard a voice once, a fleeting whisper that hinted at other minds, other worlds. But like a ghost ship passing in the night, it vanished, leaving only a ripple of wonder and a deep, unsettling silence. What other such cosmic messages, perhaps even more significant, have we missed in the dark currents of history, swallowed by the infinite void before we even knew they were there? And what terrifying truths might those lost signals have carried? The universe keeps its secrets well, and the wow signal stands as an eternal monument to the ones we almost uncovered.